the online lecture for the subject operating system for the diploma students of 5th semester computer engineering unit 3rd process management. The topic cover is threads. Myself H.G. Doke from Government Polytechnic Achalpur. Let's see the COs cover of these subjects. The following are the COs for the given subjects. Now the UOs of these, that is explain the characteristics of the multithreading model. Now the contents of these threads are benefits of threads, user and kernel threads, and multithreading model. Now we have previously discussed what is meant by thread and user and kernel threads. Now here we are discuss that is a multithreading model. Now the operating system uses user level threads and kernel level threads. Now user level threads are managed without kernel support. Operating system support and manages the kernel thread. The modern operating system support the kernel level threads. Kernel performs the multiple simultaneous tasks in an operating system. In the most of the application, the user threads are mapped with a kernel level threads. Now the different methods of mapping used for operating system are as follows. Now first is one-to-one, second is that is many-to-one, and third one is that is many-to-many. Let's see the one-to-one, that is multithreading model. Now here in one-to-one model shows the user level threads with provided with a kernel level threads, means each user level thread is provided with a kernel level threads as shown in a figure. In this method, the one user level threads map with a one kernel threads. If there are three user threads, then a system create three separate kernel threads. Now this model provides a more concurrency because of the separate threads. In this method, the operating system allocates the data structure that represent the kernel threads. Here, the multiple threads are run in a parallel on a multiprocessor system. The number of threads in a system increases, the amount of memory required is also increases. Now Windows 95 XP and Linux operating uses this one-to-one threads mapping. Now only overheads in this method is created of a kernel threads for the user level threads. Now next is that is many-to-one. In many-to-one mapping means many of the user threads maps with a single threads. Now the operating system provides a block of entire multi-threaded process when a single thread is blocked, because the entire multi-threaded process is a single thread of control. So when an operating system receives any of the blocking input-output request, it's blocked the entire process. Now the thread library handles the thread management in a user space. In many-to-many models does not allow the individual process to be split across the multiple CPU. These types of relation provides an effective context switching environment, easily implemented even with a simple kernel with no threads of support. Now the green threads for the Solaris and GNU portable threads implements the many-to-one model in a past, but a few systems continues today to do so. Now what is the advantages of this? Now system performance is improved by customizing the threads libraries scheduling algorithm as shown in a figure shows with a kernel thread with provided with a multiple user threads. Now next is that is a many-to-many. Now as shown in a figure, there is a multiple kernels level threads and multiple user level threads are available. Now in many-to-many mapping, many user level threads with equal number of kernel threads. Many-to-many maps is also called as M2N thread mapping. The thread pooling is also used to implement this method. Now user level threads is created require the number of threads and there is no limitations of the user. Again here the blocking kernel system calls does not block the entire process. This model support for the splitting of processes across the multiple processor. Now next is that is a limitation of this one. Now operating system design because of the complication the system. Now next last part is that is the assignment of this. Describe the many-to-one and one-to-one multi-threading model with a diagram, or explain the advantages of many-to-one or one-to-one multi-threading model. Next question, with the neck diagram, explain the many-to-one or many multi-threading model with the advantages and disadvantages. Next question, list and explain the various types of multi-threading model with an example. Thank you for watching the video.